Cosmic Abyss, an introduction to black holes. Black holes are among the most mysterious and fascinating objects in the universe. They captivate our imagination and challenge our understanding of the cosmos. Black holes are fascinating objects in space. They are regions where gravity is so strong that nothing, not even light, can escape. This makes them invisible to the naked eye, but their presence can be inferred by the effects they have on nearby matter and light. They are regions where gravity is so strong that nothing, not even light, can escape. This immense gravitational pull is due to the black hole's incredibly dense core, known as the singularity, where all its mass is concentrated. Imagine a place where the fabric of space and time is warped beyond recognition. That's a black hole. The intense gravity distorts space-time, creating a gravitational well so deep that anything that ventures too close is pulled in and cannot escape. Their existence challenges our understanding of the universe. Black holes defy the laws of physics as we know them, pushing the boundaries of our knowledge and forcing us to rethink our theories about the nature of reality. They inspire awe and wonder. The idea of a place where the normal rules of physics break down is both terrifying and exhilarating, sparking curiosity and driving scientific inquiry. Black holes are not empty voids. They are incredibly dense objects with a gravitational pull so strong that they can capture and consume anything that comes too close, including stars, planets, and even light. They are remnants of massive stars that have collapsed under their own gravity. When a massive star exhausts its nuclear fuel, it can no longer support itself against the force of gravity and collapses into a black hole. They are cosmic monsters with immense density and gravitational pull. The core of a black hole, or singularity, is a point of infinite density where the laws of physics as we know them cease to apply. Their influence can extend for millions of light years. The gravitational pull of a black hole can affect the orbits of stars and planets in its vicinity, and even influence the structure and evolution of entire galaxies. They shape the evolution of galaxies. Many galaxies, including our own Milky Way, have supermassive black holes at their centers, which play a crucial role in their formation and development. Black hole studies are at the forefront of astrophysics. Researchers use advanced telescopes and space observatories to study black holes and gather data that can help us understand these enigmatic objects. They push the boundaries of physics as we know it. The study of black holes challenges our understanding of fundamental concepts like space, time, and gravity, and drives the development of new theories and technologies. Scientists are constantly trying to unravel their mysteries. By studying the behavior of matter and light near black holes, researchers hope to gain insights into the nature of these objects and the fundamental laws of the universe. What happens inside a black hole? This is one of the biggest questions in astrophysics. The extreme conditions inside a black hole are beyond our current understanding, and scientists are working to develop new theories to explain them. How do they interact with their surroundings? Black holes can have a profound impact on their environment, influencing the orbits of nearby stars and planets, and even affecting the formation of new stars. These are just a few of the questions that keep us up at night. The study of black holes is a journey into the unknown, pushing the limits of our knowledge and expanding our understanding of the universe. Stellar nurseries, the birthplace of stars. These regions are some of the most fascinating and dynamic places in the universe. They are the cosmic cradles where new stars are born, and they offer a glimpse into the processes that have shaped our own solar system. Stars, like our sun, are born in gigantic clouds of gas and dust called nebulae. These nebulae are often remnants of previous stars that have exploded in supernovae, scattering their material across space. Over time, this material can coalesce to form new stars, continuing the cycle of stellar evolution. These nebulae are spread across vast distances in space, often spanning hundreds of light years. They are composed primarily of hydrogen, the most abundant element in the universe, along with traces of other elements like helium, carbon, and oxygen. The sheer scale and beauty of these nebulae are awe-inspiring, with their intricate patterns and vibrant colors. Within them, gravity acts as a sculptor, pulling together clumps of matter. This process can take millions of years, as the gas and dust slowly come together under the force of gravity. As these clumps grow larger, they begin to collapse under their own weight, forming dense regions known as protostars. As these clumps grow denser, they heat up. The temperature in the core of a protostar can reach millions of degrees. This intense heat is generated by the gravitational energy being converted into thermal energy as the material falls inward. This heat comes from the friction of the particles colliding. As the particles move closer together, they collide more frequently, generating heat. This process continues until the core temperature becomes high enough to ignite nuclear fusion. As the temperature and pressure at the center of these collapsing clouds reach a critical point, something incredible happens. Nuclear fusion begins. This is the moment when a protostar becomes a true star. The fusion of hydrogen atoms into helium releases an enormous amount of energy, which counteracts the force of gravity and prevents the star from collapsing further. This is the process where hydrogen atoms fuse together to form helium, releasing an incredible amount of energy. A star is born. This energy radiates outward, lighting up the surrounding nebula and creating the brilliant glow that we see from Earth. The life cycle of a star is a delicate balance between gravity, which tries to crush it, and the outward pressure from nuclear fusion, which tries to make it expand. This balance is known as hydrostatic equilibrium, and it allows the star to remain stable for most of its life. This delicate dance can last for millions, billions, or even trillions of years, depending on the star's mass. Massive stars burn through their fuel quickly and have shorter lifespans, while smaller stars can burn for much longer. Throughout their lives, stars undergo various stages of evolution, from the main sequence to red giants and eventually to their final stages as white dwarfs, neutron stars, or black holes. Each stage of a star's life is a testament to the incredible forces at work in the universe, shaping the cosmos in ways we are only beginning to understand. The circle of stellar life, from dust to fusion. The universe is a vast and wondrous place, filled with countless mysteries and marvels. Among these, the life cycle of stars stands out as one of the most fascinating processes. It all begins with cosmic dust clouds, also known as nebulae, which are the birthplaces of stars. These regions in space are teeming with gas and dust, waiting for the right conditions to give birth to new stars. Stars spend the majority of their lives in this state of equilibrium, fusing hydrogen into helium in their cores and radiating light and heat into space. This process, known as nuclear fusion, is what makes stars shine so brightly. The energy produced in the core of a star travels outward, eventually reaching the surface and radiating into space as light and heat. This delicate balance between gravity pulling inward and pressure pushing outward keeps the star stable for millions or even billions of years. Smaller stars like our Sun live long and relatively peaceful lives. These stars, known as yellow dwarfs, can shine steadily for up to 10 billion years. During this time, they provide the necessary warmth and light to support life on any surrounding planets. Our Sun, for example, has been shining for about 4.6 billion years and is expected to continue for another 5 billion years before it exhausts its hydrogen fuel. They eventually exhaust their hydrogen fuel and gently expand into red giants. As the hydrogen in the core is depleted, the core contracts and heats up, causing the outer layers to expand and cool. This transformation into a red giant marks the beginning of the end for these stars. Despite their peaceful lives, their final stages are marked by dramatic changes. However, the most massive stars, those many times heavier than our Sun, live a fast and furious life. These colossal stars, known as supergiants, burn through their fuel at an astonishing rate. Their immense mass creates extreme pressure and temperature in their cores, leading to a much shorter lifespan compared to smaller stars. They burn through their fuel much more quickly, creating intense heat and pressure in their cores. This rapid consumption of fuel results in a series of nuclear reactions that produce heavier and heavier elements. The core of a massive star becomes a cauldron of nuclear fusion, where elements like carbon, oxygen, and silicon are forged. This allows them to fuse heavier elements like carbon, oxygen, and even iron. The process of creating these elements is known as nucleosynthesis. As the star continues to fuse heavier elements, it builds up layers like an onion, with each layer consisting of different elements. This process continues until iron is formed in the core, which marks a critical point in the life of a massive star. This process of element creation is essential for life as we know it. Without the fusion processes in stars, the universe would lack the diversity of elements necessary for the formation of planets and life. The elements created in the hearts of stars are eventually dispersed into space when the star reaches the end of its life, enriching the interstellar medium with the building blocks of life. The carbon in our bodies, the oxygen we breathe, and the iron in our blood, all these elements were forged in the hearts of dying stars. When a massive star exhausts its fuel, it undergoes a catastrophic explosion known as a supernova. This explosion scatters the elements created in the star's core into space, where they can become part of new stars, planets, and even living organisms. In this way, the death of one star can give rise to new life elsewhere in the universe. The remnants of these stellar explosions, such as neutron stars and black holes, are some of the most extreme objects in the universe. They serve as a reminder of the incredible power and complexity of the processes that govern the life and death of stars. From the humble beginnings of cosmic dust to the creation of the elements that make up our bodies, the story of stellar life is a testament to the interconnectedness of all things in the universe. A star's grand finale, supernova. When a massive star finally exhausts its nuclear fuel, it can no longer support itself against its own gravity. The core collapses in a fraction of a second, triggering a catastrophic explosion, a supernova. This explosion is one of the most powerful events in the universe, outshining entire galaxies for a brief period. During a supernova, the star ejects its outer layers of gas and dust into space, enriching the surrounding interstellar medium with heavy elements. These remnants of dead stars become the building blocks for new stars and planetary systems. But the core of the star faces a different fate. It continues to collapse under its own immense gravity, becoming denser and denser. Collapse into darkness, the birth of a black hole. If the core of the star is massive enough, something truly remarkable happens. The gravitational collapse continues until the core is compressed into an infinitely small point. This point is called a singularity. The singularity is a place where our current understanding of physics breaks down. It has infinite density and zero volume. Surrounding the singularity is a region of space-time so warped by gravity that nothing, not even light, can escape its pull. This region is called the event horizon. The event horizon is the point of no return for anything that ventures too close to a black hole. Once something crosses the event horizon, it is destined to be swallowed by the singularity.